I welcome you all to this presentation on binomial. Now on this one, we'll just answer question 7A and B from 2022. Yes, additional mathematics. So here we have this question. The term independent of x in the expansion of this x squared plus k over x to the power 4 close bracket is equal to 6 is 60. Find the value of the constant k. So to answer this one, what we need to know is the quick formula where we use the term at which this one is going to be independent. So writing this, we'll say this is a. We want to answer this one, so we can say it's like this, then r plus 1, which is equal to, so here we'll just write the formula, which is n, which represents this number here, then r, here we'll say it's a the power n minus r, then b to the power r. So this is the simple formula that we are going to use. So just to answer this one, we'll say we'll use this part where we will say this one, which is the expansion, which is x squared plus k over x to the power 4, 6. This is a and this represents b. Then 6 represents n. Then what we don't have is what? R. That one will determine the independent term. Okay. Will give us the way to find the nth term. This we have a, it's represented by this one, x to the power 2b, this one k over x to the power 4, then 6 represents the nth term. Then what we don't have is the value for r. So what we'll do here, we'll just write this, which is where there is n, we replace by 6. So we say 6 combine r, then where there is a, we write x, 2, we close bracket, then 6 minus r, then here we have where there is b, we put that, which is k over x to the power 4, okay, then r. So this is what we have. So having this, we can rewrite this in negative exponent. We can rewrite this to a negative exponent where we'll say 6 combine r, then there's multiplication, then we can, okay, just say x, when multiply there we'll have 12, then 2r, then this one can be written as k x to the power negative 4, then there is what? R, as you can see, there is R this side. Okay, so it can be written like this. Yes, it can be written like this. So having this, we'll just get where there is a base of what? X, where there is x. So in this case, we say our x, we take this x to be equal to what? To be raised to a power 0. So when you are calculating for an independent term, what it is, you just consider the where there is what the coefficient of x. So the where there is x, that's okay. When you are calculating for independent term, you just concentrate where there is what x and their powers. That's all. So like in this case, we just take this and this one. So when we substitute, we'll take this. In fact, we are not going to substitute, but we just take them. So we'll say x to the power 12 minus 2r. So there is multiplication. Again, we have x to the power negative 4r, which will be equated to. So for us to find the independent term, this x, we put x to the power what? 0 raised to power 0. That one will give us the independent what? Term of x. So adding this one, we were saying that we're going to cancel all this x, then we remain with the power. So we have 12 minus 2r, then there is minus 4r, then is equal to 0. So having this one, we are saying that this and this, it will give us 6. So it will give us 6. We'll say 12 minus 6r is equal to 0. So whatever that you are going to do here, our r is going to be 2. So our r is going to be 2. And remember, this is not our answer. The answer that we have been asked is to find the constant value of k, this k. But here we've found that our r is 2. So this one will help us to go and replace where there is what? Where there is r, we will replace by what? By this 2. So now we'll consider this one here, or we can pick it from there. So you can pick it from here where there is this and this. So now this side we equate to 60, as we are told that this expansion was equated to 60, is giving an answer to 60 once we find the independent term. So in order for us to do that, okay, due to space, allow me just to handle this work from this side. Okay, from this side. So here, do it from here, from this side. So this side we have we have this one. So just pick it from this side. Okay, so we have, we'll say 6 combine. So where there is r, we replace by 2. These 2 that we've answered, we replace by 2. And then multiply by, here we have x. We have x squared, open bracket, then there is 6 minus r is 2. Okay. Then again, there's a multiplication there, that we have k over x to the power 4. Then again r. Okay, so all this should give us what? 60. This is what you have told, that we'll get what? A 60. So adding this, we are saying that 6 combine 2. 6 combine 2, here we get is 15. When you place this on a calculator, get 15. 15, this 6 take away 4, or 6 take away 2, it will give us 4. 4 by 2, it will give us what? 8. So there we're going to have x to the power 8. Then times, this is x, this is times. Okay, here it's k squared over x to the power 8 is equal to 60. So this x and this x will do what? Will cancel, will reduce to 1 because the powers are what? Are equal. So they will divide to 1. So here we just remain with 15, even this side with what? K squared. So you have 15 k squared is equal to 60. So adding this, we divide by what? 15. Even this side by what? 15. There goes. So our k squared is equal to 4. So to find the value of k, we introduce the square root both sides. So this k is going to be plus or negative or minus 2. So this is the value of what? K that we have found. If you want, again, you can just separate them. We'll say, therefore, k is equal to 2 or k is equal to negative 2. Thank you for A, which means we've just answered for A. Now we remain with question B. Okay, so now the second one is find the coefficient of x in the expansion of open bracket 2 plus 3x close bracket to the power 5, then open bracket 1 minus 2x close bracket to the power 3. So in order for us to answer this one, we are going to use the Pascal's way of answering. So in case, just to those who doesn't know how to come up with this Pascal theorem, remember we are told that it's more like an highlight where we say we have 1 here. So there, this one, we are going to write it. So this is a 0 term. So this is the first term 1. So to write the second, it's going to have 1. 1 plus 1 is to give us 2, then 1. So this is 1, 2. So this is the first term. This is second term. Okay. And again, so to write another one, you start 1, 1, 2 is 3, 1, 2, 3, then 1. This is the third term. Then the fourth term, we'll say, so you start 1, 1 plus this one to give us 4, this and this it will give us 6, this and this it will give us 4, then 1. So a fifth term, like the one that we have been given there, to the power 5, to the power 5, we'll start 1. 1 plus 1 is 5. 4 plus this one, it will give us 10. It will give us 10. Then this and this again, it will give us 10. This and this, it will give us 5, and then 1. So end there. You know, you can proceed as long as you are calculating, you're doing what the correct thing, okay, for the Pascal's theorem. So here our consideration is only this one, the one with the power 3, and this one, the one with power 5. So having this, we'll say, we'll simply write like this. Let's say we have the first one, which is 2 plus 3x, sorry, 3x to the power 5. So having this, we are saying that this is A and this is what? B. So having this one, we are going to expand this using what? This one, which is Pascal's theorem. So the first one is going to be, let's say we'll use A and B. We'll say it's A, we consider 1, A to the power 5, then B to the power 0, which is this 5. It will be there on, it will be, A will be raised to power 5, then B to power 0. When you add, you get what? 5. Then plus, the second one is 5 there, so we have 5, then A to the power 4. So A is being reduced, or it is reducing bit by bit, then B is being what? It is ascending. So we are writing this B in ascending order, then A in descending order. Then plus, where there is 10, we have 10 here, 10A to power 3, then B to power 2. Okay, so for this one, just allow me to hang. Okay, let us just finish. Then plus 10A to power 2, then B 3. Okay, plus 5A to power 1, B power 4, plus 1A to power 0, B power 5. So this is the expansion of what? Of this one using the Pascal. So now replacing there, we just replace where there is 2 replaced, where there is A replaced by 2. So, and 1, we know that once we multiply 1, it will just be 1, so 2 to the power 5. Then whatever that you are going to put on this B, since it is raised to power 0, it will just be what? A 1. So whatever that you are going to do, it will be the same. So allow me to omit this state. Then 5 is 2 to the power 4. Then B, it's just 3x to the power 1. Okay, then plus 10 here, A it's 2 to the power 3, then B is 3x, okay, to the power 2. Now considering the question what you have been asked, what they want, find the coefficient of x, just x without any power, which is just x to the power 1. So what I've written here, they are just okay, so we can hang there and then we just put this showing the continuity. So once we multiply this, we are going to have this one is 32 plus this square D to give us 16 times 5 to give us 80 times 3x to give us 240x. Okay, so even this one is going to give us x to the power 2. So which means this one also is going to be what? Omitted, or should not be what? Considered. So here for this one, I'll end on this one. Then let's also do the second expansion only, which is 1 minus 2x to the power 3. So this one will take this. So using the same, one, it will be A is equal to 1, A to the power 3, then B to the power 0 plus 3, A to the power 2, then B to the power 1 plus 3A to the power A to the power 1. So here it will be A will reduce to the power and then B to the power 2 plus 1A to the power 0 and then B to the power 3. So this is it. Here again we'll place A, B. So writing this, we are saying that where there is A, we'll write just 1 to the power 3. Then B, whatever that you are going to put on the value of where there is B, we'll get we'll just get 1 again. So plus 3 there, where there is a, it's 1 to the power 2, then b it's negative 2x. Okay, then plus again 3, our a again there is 1, then b is negative 2x, then square. So even this one we can hand here. Okay, we can hand it there. So just say plus continued, showing continued. So here is equal to there, it's just 1 plus this one. When we multiply this and this, so here we'll get a negative 6x, okay, plus this one is 4 times this is, so we'll get 12x squared plus, so writing this, completing to write this one to be 1 minus 6x plus 12x squared plus, so now here we'll get this one, and also we multiply with this one for us to find, to finish the expansion that we have been given. So once you multiply this one and this one, that's where we're going to get what? The final answer. So now having this one, which is 2 plus 3x to the power 5, we are multiplying it with 1 minus 2x to the power 3. So here, remember we have this one and this one. So once we multiply, let's say we write 32 plus 240x, 240x, okay, plus, then we close. Again, you are multiplying 1 minus 6x plus 12x squared plus, we close. So the reason why I've written like this, the guidance here is on the coefficient. The coefficient they want is just for x with a highest power of 1. So what we do here, we just multiply 32 times this one. It will give us what? 32. Okay, minus 32 times negative 6x, it will give us 192x. Hope you are following. Okay. Then 32 times this one. So as you can see, again, this one it will be more than what you have been told. Here the degree is just what? X to the power 1. X raised to power 1. So once we include this one, which means it's going to be what? It's not going to be considered. So we can hand here, we'll just say plus. We also jump to, since we've done with this one, we can also do with, we can also multiply this one. We can multiply this one. This times this, we're going to have 240x. Again, when we multiply this 240x times the negative 6x, this x and this x, they are going to have a degree of, or x will be raised to power 2, which should not be what? Which should not be included in our answering. So what we do, just say plus, we put something like this, showing the continuity of the expansion. So here again, your consideration is just on the x to the power 1, x raised to power 1. That is where your consideration is. So what you just do, you say is equal to this and this. So pick 192x plus 240x. So 192x, negative 192x plus 240x, what is your answer? So here we would like to write the answer. So once you have this, you take your calculator, you find that your answer is what? 48x. So this x is raised to power, this x is raised to power 1. So our final answer will say the coefficient of x is 48. So this is our answer. So here our answer is just what? 48. So when writing this 48, you exclude what? X. Thank you for following, and make sure that you share the content so that we keep on posting.